Hello. Today we're going to demonstrate three methods for deploying OpenShift virtual machines in OpenShift environments. If you're considering Red Hat OpenShift virtualization or KubeVirt, you likely have questions about how VMs are created and managed within the OpenShift ecosystem. For those coming from traditional virtualization platforms like VMware, the OpenShift approach to VM management may seem indirect or even mysterious. This demonstration will show you how it works in practical terms and highlight the advantages of different deployment approaches. We'll walk through three distinct methods. First, we'll show you how to deploy a virtual machine using the standard OpenShift CLI tools, giving you direct control through YAML manifests. Next, we'll demonstrate deploying a VM using the Digital Rebar platform user interface, which simplifies the process while maintaining visibility into what's happening behind the scenes. Finally, we'll demonstrate how to deploy multiple VMs as a cluster using DRP's cluster construct, showing how you can manage groups of related VMs as a single logical unit. Each method offers different advantages, and understanding all three gives you flexibility in managing your OpenShift virtual environments, whether you prefer command line efficiency, intuitive UI workflows, or coordinated multi-VM deployments. Let's look at deploying an OpenShift virtual machine with the CLI. This is the most direct approach to creating VMs in an OpenShift environment. To create a VM using this method, you need to request it from the OpenShift cluster using its API. The most direct way to do this is through the OpenShift OC command line interface. The process begins with creating a detailed YAML manifest that describes exactly what VM specifications you want. This manifest includes everything from CPU and memory allocation to disk configurations and networking. When you apply this manifest, it's checked or reconciled against the current cluster status. Since we're creating a new VM, it will be scheduled on a specific worker node based on resource availability and constraints. Once the OpenShift agent or kubelet running on that worker node sees the scheduled request, it will launch the KVM virtual machine. This decoupling between the API call and the actual VM creation is by design, following the OpenShift reconciliation pattern. After the VM starts, its state is monitored, but you'll need to explicitly query the API to check on its status. This approach gives you powerful scriptability, but requires more commands than most VM administrators are accustomed to using. Here's our workspace. We have pre-configured environment and variables for authentication and communication with OpenShift. As you can see, we've deployed a cluster with 3 worker nodes and 3 compute nodes. We also have a load balancer that isn't represented here. To start, we'll create our namespace named VM workloads. I've already prepared the YAML, and we can use the ocapply -f command to create the namespace. Next, we'll create the VM. I've prepared this YAML ahead of time as well. Note that we're using a container disk and no persistent storage, so the VM is entirely ephemeral. We can create the VM with ocapply. This process takes about a minute, so we've sped up this portion of the video. As we wait for the VM to deploy, OpenShift is reconciling our request, scheduling the VM on an appropriate node. Now that the VM is deployed, let's log into it. As you can see on our workstation, we're running a 5.14 kernel. When we SSH into our VM, we can see it is running a 6.14 kernel, confirming we're in the virtual environment. Finally, we can delete our VM. We'll watch as the VM is removed from the OpenShift cluster, and this demonstrates the full lifecycle management through the command line. Now let's look at creating OpenShift virtual machines using the DRP user interface. This approach significantly simplifies the process while maintaining full compatibility with OpenShift principles. Digital Rebar automates the complex VM creation process with a straightforward declarative interface. When you create a machine in the DRP web portal CLI or API with KubeVirt flags, it handles all the underlying OpenShift API interactions automatically. In this approach, we create a machine object in the DRP interface, which triggers the KubeVirt plugin. The plugin then generates and applies the appropriate manifest to OpenShift, which triggers the same reconciliation and scheduling process we saw in the CLI demo. Finally, the OpenShift virtualization operator allocates our VM on an appropriate node. What makes this method particularly powerful is the bidirectional integration. When the VM starts, it connects back to Digital Rebar and triggers configuration workflows. This creates a complete feedback loop where DRP not only deploys the VM, but also actively manages its configuration and lifecycle. This integration gives you the simplicity of traditional VM management while leveraging the power and flexibility of OpenShift. You're presented with a clean, user-friendly interface with forms instead of YAML, but still maintain visibility into the OpenShift objects being created behind the scenes. All right, here we are in the DRP user interface. Let's click Provision to bring up our provisioning wizard. We'll give our VM a name of OS Wizard since we're using the wizard. And make sure to select our OS VM workloads data profile. We'll set our initial workflow and select a color and icon. Let's bring in our status monitor and click Save. And you can see as soon as we click Save, our VM is scheduled. If we go look at our profile, you can see that we've set two variables, the KubeVirt cluster. This tells us which cluster the VM will be deployed in, and the KubeVirt namespace, which tells us which namespace within the cluster to deploy the VM. Now we can watch as the VM is deployed and runs through the standard discovery process. This process takes about a minute, so we've sped up this portion of the video. After the VM is created, we can see it's registered in DRP, which gives us additional management capabilities beyond what OpenShift provides natively. To verify our VM is running, we can check both the DRP interface and OpenShift. This dual visibility gives us comprehensive management options. When we're done with the VM, we can easily delete it through the DRP interface. You'll notice that the VM is removed both in DRP and in OpenShift. Running from DRP ensures the systems stay synchronized. Now let's look at creating a cluster of VMs using DRP's cluster construction capabilities. This powerful approach takes VM management to another level by coordinating multiple machines as a cohesive unit. Digital Rebar's cluster objects automatically build and manage groups of machines on your behalf. When you define a cluster in DRP, you're essentially creating a blueprint for multiple related VMs that will be deployed and managed together. Going a step further than individual VM management, the cluster approach leverages batch-level workflows. When we create a cluster in the DRP interface, it triggers the KubeVirt broker to generate multiple VM manifests according to your specifications. These manifests are then reconciled and scheduled in parallel by OpenShift's virtualization operator. The result is multiple VMs being provisioned as a coordinated group, with each VM automatically checking into Digital Rebar. The cluster then drives these VMs through their target workflows in a synchronized manner. What makes this particularly valuable is the ability to change, expand, or destroy the VMs behind the scenes while maintaining the logical structure of the cluster. This is ideal for deploying application stacks, development environments, or any scenario where you need multiple interrelated VMs. The cluster approach combines the best of both worlds, the power and flexibility of OpenShift-based virtualization with the operational simplicity of managing a single logical object representing multiple machines. So here we are in the DRP interface. Let's bring in our machines monitor and our CLI OpenShift monitor. We'll give it a name here, OSVM workloads. We'll select our KubeVirt broker. We want to make sure to set our pipeline. I'm going to set our universal application discover pipeline. We'll make sure and we'll set a icon. Make sure they match. Next, we set our KubeVirt cluster and KubeVirt namespace variables, which specify where in OpenShift our VMs will be created and managed. And then Save, and we see that immediately our VMs are scheduled. After clicking save, we can see that our VMs are immediately scheduled. DRP begins creating the cluster, and behind the scenes, it's generating separate VM manifests and applying them to OpenShift in parallel. This process takes about a minute, so we've sped up this portion of the video. Each VM in the cluster can be customized with specific parameters, or we can apply uniform settings across all VMs. For this demo, we'll keep the configuration consistent across all machines. Once our cluster is operational, we can scale it up just by changing the cluster count variable and running our base cluster blueprint again. This allows us to easily add more VMs to our existing cluster as needed. Once the VMs are up and running, we can also scale our cluster down using the same process. This flexibility allows us to adapt our infrastructure to changing requirements without needing to recreate everything from scratch. This process takes about a minute, so we've sped up this portion of the video. Finally, we can delete our cluster with a single action. DRP will coordinate the removal of all VMs in the proper sequence, completely cleaning up all our VMs and ensuring clean teardown of resources both in DRP and OpenShift. Thank you for watching this demonstration. If you have questions about OpenShift virtualization or DRP integration, please reach out to our team to accelerate your OpenShift virtualization journey today. Thank you for watching this demonstration. If you have questions about OpenShift virtualization or DRP integration, please reach out to our team to accelerate your OpenShift virtualization journey today.